You are able to see my screen, right?
Yes, sir. We are able to see your screen.
Yeah, okay, okay, sure. You are recording the whole thing, no, ma'am?
Yeah, I'm recording.
Oh, okay, okay, sir.
Yeah,
Thank you. Thank you, sir.
We will start in just few minutes.
Sure, ma'am, sure.
Sir, we will wait for just 2 more minutes, then we will start.
Sure, sure. Okay.
So
Yes, sir.
we are waiting for some participants to join.
Sure, no problem.
Saudi madam, are you here?
Yes, sir.
Should we start?
Yes, sir.
Okay. So warm welcome to Dr. Prashant R. Nair for delivering this lecture on Industry 4.0 building block. Also warm welcome to Bada Panda sir, who is chair of PLS chapter, IS chapter and IRC of IEEE Madhya Pradesh section, and all the participating in audience. Let me first give a brief introduction of Dr. Prashant Nair. He is working as vice chairman IQAC of Amrita Vishwavidyapitham, Coimbatore, India. He has over 22 years of teaching, research, mentoring, training, consultancy, and academic administration experience. He has taught. He has taught in academic programs in the USA and Europe at University of California, San Diego, Sofia University, Bulgaria, and University of Toronto, Italy, as an Erasmus Fellow. He has written 6 books, edited 2 books, 1 book chapter, and he has over more than 50 publications in reputed journals, books, and conferences. He has mentored students' teams which have won premier international and national competitions like Smart India Hackathon, Rajasthan Hackathon, TCS Digital Twin Challenges, etc. As part of India National Hackathon team for Singapore Team India Hackathon and facilitated by Honorable Prime Minister of India, Sri Narendra Modi ji. He has also been ranked as top innovation mentor in India by Atal Innovation Mission and Corporation AIM activities of Tamil Nadu, a regional mentor of change. He has been serving as the chairman, vice chairman, coordinator of Amrita Deemed University Internal Quality Assurance Cell IQAC since 2009. He has coordinated 3 cycles of NAC accreditations, NBA accreditation, NIR ranking, and also served as UGC nodal officer for university. A very short after speaker by conservation estimates, he has addressed I think around 150,000 students and trained around 50,000 plus facility on technology, innovation, professional bodies, and quality aspects of higher education. So a warm welcome to Dr. Prashant Nair. I invite him to deliver his lecture on Industry 4.0 building block. Thank you.
Yeah, thank you very much, Dr.
Prashant. Prashant, how are you?
Durgesh ji, namaskar, Durgesh ji, namaskar.
Namaskar. Happy to see you in this platform in the MP, IEEE MP section.
Thank you. So nice to see you.
Yeah. Good. Excellent.
Thank you.
Please continue.
Yeah, thank you, sir. Professor Manmat K. Badapanda, Chair, Professor Dr. Durgesh Mishra ji, Akhilesh sir, Shravani ma'am, other members, all chapter of IEEE Madhya Pradesh section, and the various affinity groups and chapters like PELS, IES, and IRC. Very good afternoon to all of you. So I'll just give a quick overview about Industry 4.0, the building blocks, which is essentially the area of research that I am currently working on. So my PhD was in Industry 4.0, and we tried to develop a new model for the measurement of the impact of cutting-edge ICT technologies like business analytics, cloud, and so on in the supply chain and manufacturing paradigm. That was the topic of my thesis, and it got very good. It got very good reviews and very good commendation from the French examiner, and also it was one of the best thesis adjudged in an international manufacturing conclave that happened in the US. So I'll just, this is a basic talk, and I'll just try to give you some basic idea about the building blocks so as to speak based on my, of course, this is not based on my research, but what about the building blocks of Industry 4.0. So again, very happy to be part of this Madhya Pradesh section activities. I am very active in IEEE. I chair the IEEE TV Advisory Committee in the MGA, that is the Membership and Geographical Activities Board, and also I am currently the editor of the Region 10 newsletter, the managing editor of the IEEE Region 10 newsletter, which is the Asia Pacific region. I used to hold a lot of positions in the Madras section. I was the chair of publications. I was a joint secretary for some time, and so on. So let's just get into the topic of the Industry 4.0 and its building blocks. So we have now seen 4 industrial revolutions, so as to speak. The first industrial revolution happened at the end of the 18th century. The second industrial revolution happened at the beginning of the 20th century. Third industrial revolution was very active till almost a decade back, from 1970s to almost 2010. And from the last decade, we have the decade and rather and a half, we have been seeing this advent of the fourth industrial revolution. Some say we have already moved on to the fifth industrial revolution, where there is collaboration between robots and humans. To some extent, at a research and at a level, some things are actually happening, but it is still to completely realize. So the first industrial revolution was generally because of the steam engine. The steam engine was the driver for the first industrial revolution, and the steam engine resulted in manufacturing in factories that started production and manufacturing of items. It resulted in railways becoming a major logistics provider, where goods and people were transported using railway, and that kind of expanded into many dimensions from 1760 to 1840. Now, the fag end of the 19th century, from 1870 to 1940, we had mass production, we had electricity, and the assembly line. Now, the assembly line became a norm. All factories, all manufacturing setups started having an assembly line. Manufacturing became assembly line. And one company I want to very much point out, that was probably the harbinger of the second industrial revolution, is none other than the Ford Automobile Company. Imagine, they sold 1 million cars, not now, they sold 1 million cars in the 1920s. Imagine at that point of time, a car or an automobile was it was like a luxury, but they were able to mass produce cars using the assembly line, using the best technology available at the time, and be able to cater to an upper class, and upper middle class American family. And you can imagine, in that time, he sold 1 million cars, Henry Ford. So that was the harbinger of the second industrial revolution, so as to speak. The third industrial revolution, of course, is synonymous with microprocessor, electronics, miniaturization, semiconductors, personal devices, computers, and of course the internet, the World Wide Web, that has pervaded every aspect of our life. Of course, it is the hardware that definitely hardware and software are complementary to each other, and there were advances in both hardware and software. But having said that, the hardware miniaturization, where you are having 1 billion active elements, intelligent elements in a small nanometer Pentium chip, that kind of a miniaturization and advancement set the tone for the advancements in the hardware. If you ask me, between hardware and software, the rate of development of hardware has been much more accelerated than software. So that kind of thing happened, and miniature microprocessors, microcontrollers, and that kind of broad devices that not only computers, devices that became intelligent. And of course, you need the software to run those devices, and that also happened, albeit not as fast as the hardware boom. Now we have reached this fourth industrial revolution. It's still going on. We are rather, to some extent, we are moving on to the fifth industrial revolution. Some people are even talking of industry 6.0. But the last decade and a half, we saw two movements happening. Of course, the powerhouse that is Germany is responsible for coining this term called Industry 4.0. Industry 4.0 was coined in Germany. That is, at the same time, more or less, the US, all the major US manufacturing companies ganged up in the form of the Smart Manufacturing Leadership Coalition, and they were also parallelly working on cutting edge technologies for manufacturing, smart manufacturing, and so on. Of course, today probably all these have converged into Industry 4.0. Everybody is talking, even in the US, instead of smart manufacturing, people are talking about Industry 4.0. Now, what is this Industry 4.0? The Industry 4.0 makes the factory smart. It makes manufacturing smart. It makes logistics smart. It makes transportation smart. But what is this? What is the building block? What is the bedrock? Well, the core of the Industry 4.0, the smart manufacturing, the smart factory is nothing but a simple term, that is the CPS, or the cyber physical systems. That is the core of the Industry 4.0, the smart manufacturing revolution. The core is this CPS, or the cyber physical systems. And what are these cyber physical systems? These cyber physical systems monitor physical processes, manufacturing processes, logistics processes, transportation processes. At the same time, while they monitor, they are able to make a twin, a virtual copy of those processes, and make decentralized decisions. We will come to that on what it is. Now, the core, as I mentioned, the core of Industry 4.0 is the cyber physical systems. What is the core of the cyber physical system? It is nothing but the Internet of Things. So we need to understand that perspective. The core of Industry 4.0 or smart manufacturing is the CPS, or the cyber physical systems. And the core of that CPS, along with so many other enabling building blocks and technologies, is the IoT, or the Internet of Things. That is something that we need to understand to get the bigger picture. Core of Industry 4.0, CPS, cyber physical systems. And what is the core of the CPS, the cyber physical systems? It is the IoT, or the Internet of Things. However, there are many more technologies also that are there enabling and complementing the IoT towards Industry 4.0 and the CPS. We will see that in detail. Now, technology has been accelerating in a very fast manner. And actually speaking, this COVID pandemic has also accelerated this technology leapfrogging, this move towards digitalization, smart manufacturing, digital manufacturing. All these are similar terms: smart manufacturing, digital manufacturing, smart logistics, smart transportation. To be very clear, the pandemic has also accelerated the move towards these things. I told you, people are now talking about Industry 5.0, cobot. A cobot is a collaboration between human and robot. It's already happening. Collaborative cobots are already there. Many factories in the US and Germany and some manufacturing hubs have started using robots. Already robots were there, but the robots were working in isolation. Now it is a collaboration, cobot, collaboration between the human and the robot. That kind of things are moving very fast. So technology has been accelerating in a very fast manner. If you see all these things in this slide, today, these things did not exist in 2006, but all these things are today a part of our life. I cannot imagine not having an iPhone or an iPad. For many people, it is having a mobile device. It all depends upon the 4G or the 5G. When you travel abroad, the cheapest and the best way is a Uber. Where do you stay? You use an Airbnb. There are people who don't swear by an iPhone, but they swear by Android. An Android device is their heart and soul. How can we live today without WhatsApp or Instagram? Children, students, I never knew all these students. I am very active on LinkedIn and Facebook, but I don't have a very active Instagram. But none of these students look at they tell me that Facebook is old, outdated. LinkedIn, we will see when we get into a job, we will think about it. But Facebook is for old people. That is the thing. Everybody's into Instagram. But none of these things were there in 2006. Now, how ubiquitous these things have come. And we have to understand Industry 4.0 from that perspective. We are moving towards the Industry 5.0, and it is going to be a fast-paced transformation and fast-paced acceleration. Look at this slide. These devices took 75 years to reach 100 million customers. The telephone took 75 years. The World Wide Web was faster. It took 7 years. Facebook took 4 years to reach 100 million subscribers or users. Instagram took 2 years. Couple of years back, Pokemon Go, of course, people say there are negative effects of the game, but it took 1 month. Today, if you have a killer app, an app that is extremely efficient, a killer app, this app will hit 100 million customers in a day. There are apps that can hit in an hour. That is how technology has become viral. An app, a killer app, may reach 100 million downloads. It's possible even in a single day or two. It may hit. That is how our technology is accelerating. We have to understand Industry 4.0 from that perspective. It's moving so fast. And technology is accelerating. As I mentioned, the core of Industry 4.0, the bedrock, the most important building block, the bedrock, I would say, is the cyber physical system, the CPS. The CPS is a series of collaborating computational or intelligent elements. These intelligent elements control physical entities. They make a copy of these physical entities, the virtual, some people even call it a digital twin, a twin of the physical process. And these virtual entities, physical entities, collaborate with each other, coordinate with each other, talk to each other, take decisions, not on a centralized manner, but sometimes in a decentralized manner. So there is a seamless, the boundary between the physical world and the virtual world is dimming. People are talking about metaverse. You have your digital twin. If there is a seminar now, I can talk to IEEE Madhya Pradesh section online through the medium of the Cisco WebEx. But my metaverse, my twin can do something else to the metaverse. This is the kind of things that are moving forward. But the core of this Industry 4.0 continues to be this CPS, or the cyber physical systems. And today, cyber physical systems have made the factories very intelligent, very decentralized, very decoupled, very flexible, very adaptive, and very decentralized. This is the factory of the future. It is not, we used to have an assembly line. This is how a car is being made. A car is being made, one component is added in every cog of the assembly line from one bay to another. But now we are going to see a sea change. We are going to see that these are all decentralized, decoupled, flexible, autonomous. And each of these are intelligent, modular. in nature. So that is what we are going to see with this advent of Industry 4.0. And the principles in terms of the key words in terms of this will be interoperability across platforms, across devices. There will be an interoperability and they will all talk to each other through the core of the CPS is the Internet of Things. Today people are not talking of IoT, they are talking of IoE, Internet of Everything. Everything can be smart. We will see that a little later. Now, one core is going to be the interoperability. They're going to be virtualization. Any physical process, you have a digital copy, a twin of a virtual copy of that. Decentralization of decision making. Each system, it could be an assembly station, it could be a product, it could be a device. It is autonomous, it is independent, it is flexible, it is decentralized, and it is able to it is having access to real-time data, and based on the real-time data, with the intelligence that it has got, it is able to take decisions. So these are some of the things that we are going to see. Interoperability, virtualization, of course, cloud and is a complementary technology, decentralization, real-time updating, service orientation, and modularity. These are the design principles that we are going to see in Industry 4.0. Now coming to I told you that the core of Industry 4.0 is the CPS, the cyber physical systems, and the core of the cyber physical system is the IoT, the Internet of Things. Some people even say industrial IoT. It's more or less the same IoT for the industries. But IoT is going to have the Industry 4.0 will need a lot of complementary technologies. The core is no doubt IoT. The Internet of Things, the sensor, the actuator, the device. But at the same time, there is going to be a canopy of complementary technologies that will help. Robotics, autonomous robots, simulation, 5G, communication systems, horizontal and vertical system integration. Smart manufacturing, integrating horizontally as well as vertically. Now, because of the fact that, so much of devices are there, obviously you're going to see the big data. Imagine one car can be having 100 sensors. You can imagine the amount of data that is going to be generated by one car with 100 sensors. You do the math, millions and millions of cars. So we are looking at a big data and we need to analyze that big data. And when we need to analyze, we also need to protect that big data. We need the cyber security. And some of the other things that are now also very complementary are the augmented reality, virtual reality, metaverse, and of course, additive manufacturing practices that are more efficient and proactive. So, as I mentioned, Industry 4.0, the bedrock is the cyber physical system, the CPS, and the bedrock of the CPS is the IoT, the industrial IoT. But the IoT will need a series of complementary and supplementary technologies that will support the activity. And again, what are these? They will include big data, analytics, the cloud, or the robotics, simulation, augmented reality, virtual reality, metaverse, and of course, smart practices in cyber security, securing the thing, and of course, smart manufacturing, additive manufacturing, horizontal and vertical system integration. All those kind of things will be this thing. Now, if you add some more things, of course, everything is covered here, but 3D printing, that is also going to be a very big thing in the Industry 4.0. Now, today, people are talking of a very new stack called SMAC, SMAC. I have done some research also in this. SMAC stands for S is social, M is mobile, A is analytics, and C is cloud. SMAC. People are talking of this SMAC stack becoming more and more rampant, more and more prominent, more and more predominant in all manufacturing and all these services. You have the power of social media, SMAC. Imagine today, if you take any social media, if you take Facebook, there are 2 billion monthly users. You take Instagram, 1 billion monthly users. WhatsApp, more than 2 billion users are there. See the power of the social media, right? Billions of users. 1 out of 2 or 3 people in the planet has got a social media account. You cannot ignore. You are talking of mobile apps. 800 if you take the world population in India, let us take India. I am told that the number of mobile phones in India are close to 800 million. Population of 1.4, it might have been, we may probably by now we have, this was 2 years back, now probably we are having up 1 billion phones are there in this country. And perhaps 70% of them are smart. You can imagine the apps that are there, the data that is being generated. Mobile apps, they're very big. You know, you want to check the weather, AccuWeather. You want to know the climate, windy.com. Everything is available on the app. UPI, Universal Payment Interface. The whole world is now looking at how you can adopt the UPI. See, UPI is not a new technology. Universal Payment Interface. It's always been there. Digital payments, e-cash, mobile cash, M-cash was there. But in India, if you see the scale at which the UPI has begun, trillions of transactions, whole world is now looking how you are able to scale up so much. Is it Jugaad? Frugal innovation? We don't know. All these things are there. So many technologies, social, mobile, analytics, and the cloud. This SMAC stack is going to be one of the futures. It is, of course, it is complementary to the industry 4.0. It is very complementary: social, mobile, analytics, and cloud. So these are some of the overview of the basic building blocks of the industry 4.0. Of course, the basic is the CPS, or the cyber physical system, and of course the basic is the bedrock is the IoT. Now, where are we using it? Everywhere and anywhere. Everywhere and anywhere we are using this industry 4.0, whether it is supply chain, whether it is manufacturing, whether it is communications, product data management, engineering design, tools, digital manufacturing, control systems. Everywhere and anywhere we are using these things. There is no area where we are not using this kind of technology. Rather, the supply chain has become a value chain. You know what is a supply chain? The network, the supply chain where goods are moving from, goods are being manufactured and delivered to the customers, transported to the customers. The entire supply chain is now become a digital value chain, completely integrated through this industry 4.0. And there are many complementary, there are many things happening, whether it is design, planning, production planning, manufacturing, material resource planning. Everything is getting, we are getting a connected enterprise, a digital enterprise. The entire value chain is getting digitized. And where are we? We are going to see much more. What is going to be the future? I already told you, people are talking about industry 5.0, robot assisted production. It is not only the cobot, robo and the human combining together and doing this thing. Additive manufacturing of complex parts, 3D printing, predictive maintenance, big data based, analytics based quality control, machines as a service. We have heard about SaaS, software as a service. We have heard about IaaS, infrastructure as a service. We have heard about PaaS, platform as a service. We may have heard not so much there, but hardware as a service, HaaS. Now we will see machine as a service. That is what is going to be the future. The machine, you don't need to own the machine. The machine is available somewhere. You use it as a service, pay as you pay per usage, and then move on to the next thing. This is what is going to be the next stage. The next stage in terms of the industry 5.0. Skip these slides, just some examples. Yeah. Yeah, this is just some of the companies. So everywhere and anywhere. Now, I just wanted to spend a little time on the what is the as I mentioned, the what is making the industry 4.0. It is the CPS, the cyber physical. But what is making the CPS work? It is the Internet of Things. The Internet of Things, wherein every physical and virtual thing in any environment can perceive and act. So every device is able to sense, learn, act, and operate. I will repeat. Every device is able to sense, learn, act, and operate. And what is helping in the sensing? It is the sensor. What is helping in learning? It is the cloud. And not only the cloud, but the storage in the cloud and methods to access the data, query the data, analyze the data, mine the data. And what is making it act? It is the actuator. Devices called actuators. And what is making it operate or execute? It is the hardware and software. So this IoT is this cognitive loop of sensing, learning, acting, and operating by the IoT device, the Internet of Things device, is what drives the engine of the this cognitive loop drives the engine of the CPS, the cyber physical system, and that drives the industry 4.0. I want to just show you some use cases of the power. Take if there are 8 billion people in the planet, it is estimated that already each person has got 6 intelligent devices. We are looking at 50 billion. I don't know, maybe this number might have increased. This is a projection that we will hit 50 billion smart devices, smart things. Each person will have 6 of them, but now maybe it might be much higher. You do the math, that is the thing. And everywhere and anywhere we are going to see. Just some use cases I just want to see. You are entering a big mall, a Walmart or a Kmart or a big bazaar. You are just walking. You're not meeting anybody. You're not talking to any person. You're not talking to any helper. But you are walking down the aisles of the shopping establishment. You are walking down the aisle and the goods are talking to you. I am available. I am having a discount. I just came yesterday. They are talking to you. Your mobile device or your smartphone or your tablet is getting continuous messages. The goods are talking to you. The goods are introducing you. And not only that, if you have any goods that you bought from that shop, they are connected. Oh, you bought a polo t-shirt. You bought a Versace perfume. It had an RFID. The shop knows, and they will, since you already bought a Versace perfume, I want to inform you, a new Versace perfume stock has come. Why don't you buy? And not only that, you don't talk to each other. You don't do a takeout. You don't go to the stock out. You don't have to meet anybody. You just walk off. You have your plastic card automatically, like a fast tag. Your credit card is swiped. You take the goods. You move off. Money is paid and all that. So this is not a thing of the future. This has already happened. These are already available. Albeit these things have not become so commercially viable, in the sense that they are still in the experimentation stage, they are still in the testing stage, they are still in the pilot stage, but these things have already happened. So this is where we are going to see how this technology is moving forward. Now, in terms of healthcare, there are so many sensors in your body. The sensor will tell you that your sugar level is low. You need a diabetes shot. The doctor will tell you that you are getting a heart attack. You are sweating, but you don't know that you are having a heart attack. But the doctor will be able to monitor and tell you, hey, dude, you are getting a heart attack. Immediately do this. You only know the sweating, but your parameters are being monitored real time. This is just a tip of an iceberg. So many sensors in every part of the body, right? These are not things that are going, already these things are there, but of course, albeit they are not so common, they are not cheap, they are a little expensive, they are in the pilot stage, but moving forward, we are going to see a stage where these things become cheaper and cheaper, affordable, and we will be able to see this deployment in far and wide. So this is just that's all from my side. I thought I will use this time to answer some questions also. Thank you very much for this opportunity. Thank you to the IEEE Madhya Pradesh section for this opportunity. Thank you very much. Over to you. I'll be very happy to answer any number of questions. Thank you.
Anyone have any questions for Prashant sir?
I just wanted to know what is expected from Industry 5.0. When 4.0 covers almost everything, what is expected from Industry 5.0?
Sir, Industry 5.0 is like an extension. The current research trends are talking about this collaboration between human and, I mean, it's already happening. I don't deny that. But talking of cobots, cobot is one of the things that is mainly characterized with Industry 5.0. It is like, this, if you ask me what is the difference between 4G and 5G, not much, right?
Yeah.
Something like that. So people are talking of cobot, metaverse. These are the key words that are coming in the Industry 5.0, where there will be a lot of collaboration between the robots and humans, so as to speak. But people are also talking about what is that? Connected cars, all those kind of things. This what is that? Google self-driving car. All these things are kind of you can say pointers towards Industry 5.0.
Okay. In the country, when is the 4.0 is going to be realized in practice in the country?
So we are already seeing a lot of manufacturing moving towards Industry 4.0, smart manufacturing in many factories, automobile, ancillary industries. But as I mentioned, they are, as of now, they seem to be a little expensive. So we are not seeing a wide deployment, because I myself did some survey on usage of big data analytics and so on and so forth, especially in the supply chain context. And I found out that many of these MSMEs, the Indian industry, most of the big industries have adopted in some way or the other. They are having a digital strategy. They are having a digitalization strategy, moving towards all these things. Maybe next 5 years, all the big players will do it. But we are not seeing this MSMEs rise up. That was what our research also pointed out, because we need to have open source and affordable alternatives for all these MSMEs. MSMEs cannot afford these kind of technologies. So that's where the challenge I feel is there. So we will need to, if Industry 4.0 has to expand, we will need to capture the MSME segment. In India, MSME is a very significant part of the economy. That is the challenge that we are seeing today.
Thank you.
Dr. Nair, can you please emphasize the role of IoT here? More, I mean, can you put a more light on this?
No, as I told you, sir, this IoT is the core of this cyber physical systems. And the IoT means these sensors, actuators, and these devices which help you to interface with the hardware and the software. Now, to give you an example, any physical process you can sense. For example, a physical process means, suppose there is a gas, a stinking odor is there. Of course, your nose is able to sense, but the sensor is also able to sense that. and give you, and also you can, the sensor will sense it and you can even calibrate it and say that this much percentage of poisonous gas is there. So there are sensors for anything and everything, whether it is a temperature sensor, a pressure sensor, a gas sensor. There are sensors for human body function. So you can say it is like magic, that a physical process is being sensed, being captured, calibrated, and acted upon. That is the power of the IoT, and this IoT is the core for all of these things.
Okay, okay, thank you. Any more questions? Okay, I think Dr. Shravani, you can present the vote of thanks then.
Sure, sir. A very good evening to all of you present here. Myself, Professor Shravani Mathur. I'm the Secretary of PELS IEEE MP section. I'm very honored to have Dr. Prashant R. Nair sir on the board. And sir, we are very thankful to you for your beautiful discussion and your words of wisdom and knowledge. We thanks you once again. And I would like to thanks Dr. Manmat Bara Panda sir for his continuous support and guidance to all the members and the whole MP section, PELS and IES section. I would like to thanks Dr. Durgesh Mishra sir, Dr. Savita Nema ma'am, Dr. Brahmadev Gupta sir, Ms. Rinki Upadhyay ma'am, Dr. Saji Chako sir, and last but not the least, our Mr. Akhilesh Tripathi sir, for arranging the lectures and taking the responsibility of technical issues, if any. I would like to thank Ashish Singhal sir also and Yugal Kishorji. So it's very nice to meet you all and have a great lecture by Dr. Prashant R. Nair sir. And I'm thankful to him that he accepted my invitation and delivered such a beautiful lecture. So thanks once again. Thank you all.
Yeah, thank you very much. So happy to see you, Durgesh ji. So
Yes,
nice
yes.
face to face after so much time. We are
Right,
talking
right.
regularly, but now we are seeing. Nice.
Right,
Thank you very
right.
much to everybody. Thank you so
Yes,
much. Yeah.
your session was excellent. I learned number of things here. Right,
Thank you, sir.
right. And thank you for your support here in the IEEE MP section. Thank
Sure,
you.
sir.
Thank
Bye.
you.
Okay, thank you everyone. Thanks for joining this lecture.
Yeah, thank you.